we will be discussing all the points about continuity and discontinuity on piecewise functions. So supposing you have this problem and you're trying to analyze whether this piecewise is continuous at x equals 1. We have defined a continuous function for a condition that if you have these pieces, these two pieces should be equal. So if your g of x is equal to the square root of 3x minus 2, and your h of x is equal to x squared plus 1, and they make up a piecewise function defined by f of x. To know that these two pieces will be continuous if your xy for both will be the same. That is, your g of x should be equivalent to h of x. And what does it mean? Okay, now these are actually the y values and you are given the x values. So what you should do is to make the equations equal. So you have square root of 3x minus 2 is supposed to be equal to x squared plus 1. I'm putting a question mark because I'm still not certain, because we are still trying to prove whether our equation will be continuous at x equals 1. So what should we do here? So therefore, your x value is 1 and we will plug in our x in the equation. And so you have 1 squared plus 1. So this will give us the square root of 3 minus 2 is equal to 1 squared plus 1. And so this is the square root of 1 and this is 2. And of course, the square root of 1 is 1 and the square root of 2 when 1 plus 1 is 2. And as you can see, they are not equal. It means that at point x equals 1, the piecewise function is not continuous. And you see your value of y is different for each. The value of y in this equation is at 1, and the value of y in the second equation is 2. So this means that these two functions will be different at certain points where x equals 1. At g of x, okay, your 1 will correspond to y equals 1 at x equals 1. This one, when your x is 1, your y is 2. So they are different. So therefore, this function is discontinuous at x equals 1. We can also prove this by means of graphing. Okay? So how do we graph piecewise functions using our Desmos? It will be different when you are using a calculator. Okay, so what you should do here is go to your ABC so that you can change your keypad and find this grouping symbol, which is actually braces. And then after that, set first your condition. It's actually the opposite when you're doing it in the calculator. The condition comes after. In Desmos, the condition will be written first. So your x is less than or equal to 1. And then put a colon. Then after that, put your equation. That's the square root of 3x minus 2. So therefore, this is the graph of the first piece when x is less than 1. So it means that your x here cannot be greater than 1. So it should be to the left of 1. Okay, next, we will go to the second equation. Go to your ABC first and find your braces and go back. Okay, put the condition x is greater than 1. Alright, and then put a colon. And then, of course, you write the equation x squared plus 1. And as you can see, x is greater than 1. So from 1 going to positive infinity, it cannot be less than 1. Now, in this situation, you would know where the hole is if there is no equal sign in the condition. It means that your hole at negative 1 is here, and it's actually a dot here. And obviously, it is discontinuous at x equals 1 because the y values are different at x equals 1. So what does it mean then? Okay, this is a jump discontinuity because from an equation here, it jumps out to a second equation. And so that's how you will be able to identify whether your piecewise is continuous at x equals 1. So just simply make the two pieces equal at a breakpoint. We call x equals 1 as the breakpoint. Okay? And then after that, plug in the breakpoint to the equation, and it will only be continuous if the values of your y are the same. And in this situation, the values are different, therefore, it is discontinuous at x equals 1. Alright,